Top of the morning, glad to have you with us. We have a very special guest. Dr. Claire Parkinson, who is a project scientist at NASA Goddard, is going to share with us about her experiences, about her educational background, and about some of the things that she's very passionate about, and I'm sure you will enjoy. And I'm Christine Cornelius. Don't touch that remote. We'll be right back.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff of NASA's Aqua spacecraft designed to study the Earth's water systems. And everything continues to go well.
Plus 30 seconds.
30 seconds into launch at this time.
Roger.
Thanks so for joining us today.
Thank you very much for having me.
And she is a project scientist at NASA Goddard. If you could share a little bit about what you're working on.
Well, I have two main categories of work at Goddard, and the first is my own research. And my research I've been doing there since 1978, so a long time. And the research is on examining sea ice in the Arctic and Antarctic using satellite data. The second main task that I have is to be the project scientist of a mission named Aqua that was launched in 2002. I've been project scientist since 1993, so there are 9 years before we even got any data out of it. And it's collecting data about the atmosphere, oceans, land, ice. So lots of different data sets are coming out from that satellite, which has 16 Earth observing instruments on board.
And Claire, now we're going to be going to a clip. This is interesting stuff. How did you ever get interested in science in the first place? Did you know you wanted to work at NASA?
Actually, I grew up loving math. Math was absolutely my favorite subject all the way through school. But I was in college in the late 1960s, and there were a lot of troublesome things happening. Civil rights were clearly not what they should be. The Vietnam War was going on. And even though I was majoring in math and loved math, I felt like it's too abstract. I need to get something that's more concrete. And that's when I switched from math to science. And then I got interested in Antarctica, decided I wanted to go to Antarctica. And so for my graduate work, I became a climatologist. I went to Ohio State because of their program called the Institute for Polar Studies at that time. And they got me down to Antarctica, which was very exciting. At that time, almost no females had ever been down to Antarctica. And so that was very exciting that I got to do that. And then that transitioned into my working on sea ice around Antarctica. And then when I finished my dissertation for my PhD, I was at a conference presenting the results from, it was actually a model that I constructed of sea ice. And there was an individual from NASA in the audience, and he came up to me after and he said, "Do you know what you're doing after your after you get your degree?" And I said, "I've been so busy trying to finish the dissertation that I really don't know." And he said, "Well, what would you think of working for NASA?" And it was like, I had never thought that I could conceivably work for NASA. I mean, it just immediately was my first choice.
Wow.
Back to the 60s, in the 60s, like one of the most amazing moments for me and so many people around the world was 1969 and the first landing on the moon. And to me, that moment when they put down the flag and said, "We come in peace for all mankind," I mean, that was a moment that made me so proud to be an American in a decade that there were so many troublesome things going on. And so to me, to get to work for NASA, and now I've been working for NASA for 33 years, I mean, it's wonderful. And not only the moon landing, but the rest of the astronaut program and the fact that you've got little rovers roving around on Mars. I mean, NASA does really cool things. So it's been quite a privilege to be able to work for that organization.
Well, and Project Aqua, if you could tell us a little bit about it, because I understand that there's an international flavor to that project as well.
Actually, yes, and there's an international flavor to a lot of NASA's programs. The Aqua spacecraft has 6 instruments. The spacecraft itself was built in the U.S. 4 of the instruments were built in the U.S., but 2 of the instruments actually came from other countries. 1 came from Brazil, and 1 came from Japan. And so both Brazil and Japan had major contributions to this Aqua mission. And as I said, that's not uncommon now. Now there's a lot of international collaboration that goes on in the space program.
Well, you also have me curious, because you mentioned that you actually were down at the Antarctic. What was it like to be there for a while, and how long were you there when you were studying as a student?
I was only there in January of 1974. I think it was 1974, and it was exciting just to get down there. It was exciting. We were studying the flow of ice back into a volcano had erupted, and we were measuring how fast it was flowing back in. The ice was flowing back in because when the volcano erupted, all the ice blew off.
Where was the volcano?
The volcano was right off the coast of, it was on an island right off the coast of the Antarctic Peninsula, which is, and it was Deception Island is actually the island it was on. So we were measuring the flow back into the volcano. And so it was very exciting. This was kind of like a pilot study for looking at the flow of the entire West Antarctic ice sheet, which has become of increasing importance because of the fact that if the ice flows into the ocean, it's going to cause sea level rise.
And so now you've been able to observe it firsthand and then being able to watch it, so to speak, through the data that you're collecting on the satellite. And we're going to go on a break and come back. We'll be talking with Claire more about her satellite projects and working on satellite. Welcome back. We're here with Claire. And Claire, I understand in addition to being a scientist and working on Project Aqua, you are also an author. You brought some books with us. Share with us what you've written about.
Okay, I actually quite enjoy working on books because you get to tell a full story. You know, sometimes as a scientist, we are so pressured into writing journal articles. I mean, those are very important.
And you've written many of them, from what I understand.
Yes, and those are very important, but they often are so constrained in terms of the length. And so with the book, you can tell the whole story. And so I really enjoy getting to work on books, and I'm glad that NASA allows us to work on books if we want to too. So yes, I have worked on a variety of different types of books. And like one of the first ones that I worked on was Arctic sea ice from satellite data. This was the sea ice from the first satellite data set that got us good imagery of the Arctic sea ice. And it was a satellite that was launched in December of 1972, and it got a 6-year data set. And we worked for, well, roughly a decade to get that data set in good shape. That's because this hadn't been done before, you know?
Wow.
And so now people can get a data set and they can have it all analyzed within weeks, you know? Whereas when you were first trying to do it before other people had done it before, it was a much bigger task. You know, we had to develop the techniques of how to do it. So this is very outdated now. It was published in 1987, but it's the kind of starter point to, and many of the techniques are continued to be used by other people as well as by those of us at Goddard. So then later, I wrote a book on, an introductory book on using satellite data to look at the Earth. And this is called Earth from Above, and it's kind of an educational book in terms of it's trying to explain things like, why do we have so many instruments up in space? And it turns out different instruments get us information about different things. Like an instrument that's measuring the same kind of radiation our eyes see, called visible, is going to see what our eyes would see. So you can get great records of things like clouds. You can get great records of things at the surface as long as there's no cloud in the way and as long as it's light out. But then there are other types of radiation like microwave that can see through the clouds. And so therefore you can get data at the surface even though there's a cloud in the way. So different advantages for different types of instruments. And so this is an introductory book about that. And then
so it talks about kind of the different types of data that's available and how it's used.
Yes, and then it's got 6 main examples of different, each with a chapter on a different topic, one being sea ice, one being snow cover, one being volcanoes.
So this will be a good introduction to those who are interested in satellite and space exploration.
It's an introduction, and it also is educational in the sense of there are questions at the end of each section and there are answers at the end of the book. At the end of the book. Then more recently, I worked with many people on this book, which is much more complete. This book, I was an editor and an author, but this book has many authors in it. And this book, just no matter which page you turn to, you're going to see some
beautiful.
spectacular types of images and short chapters on all sorts of topics. So this book goes more into the huge range of things that you can see from satellite data. And in this book, my main collaborators here, there were 4 of us editors. It was Michael King, Kim Partington, and Robin Williams that I worked with on this book.
And are they all at NASA?
No, Michael was, he's retired now. Kim is actually in the United Kingdom, and Robin was at Goddard when the book started, but he went to another job after. So anyway, this book, just gives is wonderful to work on because of just the huge range of things that it shows about what we can get out of the information that we're getting from space.
It's called Our Changing Planet,
Right.
The View from Space.
Right. And so all the books that I had written on, worked on up until the one that came out last year, which is this one called Coming Climate Crisis, all the books I'd worked on previously, I was really excited when they came out and everything. This is the first one that I tackled a controversial subject. As most people know by now, climate has become very controversial, and the climate system, humans are making an impact on it, and it's serious. But unfortunately, the discussion has become so polarized that people aren't getting the main message also often because of the polarization. And so,
And what's that main message that you're thinking about?
well,
that
the
they're
main
missing?
message is we've got a finite planet here, a finite atmosphere. We should be protecting it better than sometimes we are. And so in this book, what I try to do is explain climate changes, but in a way without saying negative things about people I disagree with. In other words, I feel I want the discussion to be more civilized than what it's become. So this one I was kind of worried about, and that's one of the reasons why it was so refreshing to me a year ago when I became hooked up with the Maryland Women's Heritage Center, doing something that was entirely positive, which is looking at the value of STEM careers, science, technology, engineering, and mathematics,
Yes.
and the fact that women can be involved and are involved in these STEM careers, and the positive nature of that was just so refreshing versus the work that I've continued to do on the climate issue, but is sometimes frustrating because of how polarized it's
Well, Claire,
gotten.
thank you so much for sharing, and we look forward to talking to you more about the STEM and this upcoming event with the Maryland Women's Heritage Center, too. We'll be right back. And we're back. Nice to have you. And Claire, thank you again for joining us. And thank you for sharing all of the wealth of information that you
Well, thank
have
you.
provided in the books. And I did want to follow up on what you were talking about, the STEM disciplines. If you could explain to the audience kind of what the STEM disciplines are and how important it is to get especially young girls interested in these disciplines.
Well, STEM, spelled S-T-E-M, stands for Science, Technology, Engineering, and Mathematics. And if you get a background in those topics, there are so many different careers you can go into. And a book that Goddard has done now in collaboration with the Maryland Women's Heritage Center called Women of Goddard, it gives a wonderful sampling of the types of careers you can go into. This happens to have 103 women in it, and there are all sorts of career types. And this is all just from one institution. I mean, think of how many there are if you start thinking of all the other institutions around the world.
All the other science and engineering institutions, yeah.
Right. But in this one, like there are many different types of engineers. You've got optical engineers, mechanical engineers, electrical engineers, contamination engineers. You've got all sorts of different types of scientists. I'm a climatologist, so I study climate, but you've got others who are meteorologists, you've got others who specifically are studying hurricanes, you've got others studying volcanoes, you've got others studying the universe, you've got planetary scientists, you've got scientists who are looking at dark holes in the universe, dark energy, just all sorts of possibilities of exciting things you can do. And in addition to the book, the other set of things that we've done with the Maryland Women's Heritage Center is a set of 6 posters that'll be up at the exhibit that's going to be opening on November 14th, and then will be open for about a year, is my understanding.
Right.
And those 6 posters highlight. The first one highlights the book and some of the quotes in it. Each person in the book, the 103 people, each person had to give a short quote. And so the first poster highlights some of those quotes. But then the next set of 5 posters, the rest of the posters, they highlight a mission and then 9 of the women involved in the mission. And for instance, there is one of the 6 posters is on Aqua, and since we've mentioned the Aqua mission, the top part of the poster shows the Aqua spacecraft before it was launched. It shows pictures from the Aqua spacecraft, and then at the bottom it shows 9 women who've been involved in the Aqua mission, all sorts of different ways, like project scientist, engineer who helped construct things in the beginning, an education specialist who helped get the word out about the mission, a computer scientist who helps get the data looking really good and attractive, and just all sorts of ways in which you can be involved in the mission. One of the other women is in mission control, so she's engaged in controlling the satellite as it orbits the Earth and getting the data from it.
So you too actually will be able to come and learn about these women that Claire is talking about by coming to the Maryland Women's Heritage Center, being able to see this exhibit, see the posters, look at the book, and we'll be right back after this break. Welcome back. And Claire, you mentioned some women who work on Project Aqua. If you could just tell us a little bit more about what Aqua is and the satellite.
Okay, Aqua is a satellite that's up at 705 kilometers above the surface of the Earth. It orbits around the Earth every 98.8 minutes, so they've got it tracked very carefully. It gets data about the entire globe, and it's getting the data from 6 different instruments. And there are lots of scientists around the world, in fact hundreds of scientists around the world who have used the data, and in addition to scientists using the data for their science, the data are also being used for quite a few different practical purposes, such as weather forecasting and monitoring forest fires, which can be very important when there's a forest fire out there. It's very important to get the satellite view to see how far it extends.
Where it goes. And we have a clip to share with the audience with Project Aqua. Wow, well that was really interesting. And Claire, would like to ask you if you have any last thoughts you'd like to share with the audience.
Just that it's been such a privilege to be able to work at NASA's Goddard Space Flight Center all these years, and in the past year to be able to work with the Maryland Women's Heritage Center has been quite a privilege also.
Fantastic. Well, hopefully we will get many people coming to the Maryland Women's Heritage Center to be able to see this exhibit and learn more about people like yourself and others who work at NASA Goddard. Thank you so much for joining us for the show. We look forward to seeing you next time. Well, thank you for joining us with this show. Dr. Claire Parkinson was a fantastic guest, and it was so wonderful to hear her talk about her projects and to see her enthusiasm about science. And for those of you who are considering science and engineering disciplines, please, I would ask you that you would consider that. And for all those women, too, just to recognize the accomplishments of a woman such as Claire and what she's been able to do, not only in the United States, but around the world, and increasing the amount of data and the scientific data that's available to scientists as we learn more about this Earth. I'm Christine Cornels. Thanks so much, and look forward to you next time.